Dear students, let's see this question. One end of a horizontal uniform beam of weight W. So here rod is there, beam is given, beam weight is given as W, and the length L he is hinged on a vertical wall at point O. So length is also given, length is L and it is hinged at point O. It is fixed at the point O. And its other end is supported by a light inextensible rope, and the rope end of the rope is fixed at point Q at a height L. So other end, if you see, inextensible rope is there. So one end is connected to the point P and other end is connected to the point Q. And what is given is the length of the rod is L and the length of this one also. So distance between O and Q is also L. A block of weight alpha W is attached at the point P. So at this point, one block is placed here. Block is placed. This block is placed here. How much it is? Weight is alpha W. And he is saying that the rope can sustain a maximum tension of 2√2 W. So how much tension the rope can able to sustain? The maximum to maximum of 2√2 W. He is asking that which of the following are correct. So we have to calculate. We have to find which of the statements is correct, right? So before going to that statements, first we will try to identify the basic equations. We will try to identify the basic equations, and after that we will go with the options, right? Now see here. Now here is saying that this one is rope, so tension will be in this direction, tension, right? So here this is L, this is L. So this one will be theta is equal to 45 degrees. We know already, but because this one is L, this one is L, means here theta is equal to 45 degrees. If we resolve this T into two components, in this direction T cos theta and in this direction T sin theta. Clear? Clear? And one more thing here. At this point downward, alpha W is there, alpha W weight, and again rod is there. From the center again W will be there downward. Clear? And again hinge point is the hinge point. So at this hinge point, two forces are there. One is vertical and second is horizontal. So I will write that in this direction I will write horizontal force is H and upward I will write vertical force is V. So try to understand, V and H are the vertical and horizontal forces at the point of hinge. Clear? Now the system is balanced one. It is balanced. If it is balanced, then we can able to identify x-axis and y-axis forces we can equate, right? So if you equate like this, if you see here, first equation what I will write is along vertical. Vertical, see, this is V and this is T sin theta. Vertical V, I will write solution here. We will see after solution. V plus T sin theta, which is equal to downward forces, positive y-axis, negative y-axis. Downward force is W plus alpha W. W plus alpha W. This is one equation I got. Clear? And one more equation along horizontal. Horizontal. So this one is at the point of hinge, H is towards the positive x-axis and T cos theta is towards the negative x-axis. So net force will be 0. Net force is 0, which means H is equal to T cos theta. So H is equal to T cos theta. Clear? Here if you see, here V is there, H is there, T is there. So three unknowns are there. Three unknowns, but we got only two equations. If three unknowns are there, so how many equations you have to get? Three equations, right? So now the third one, we will see the rotational equilibrium. One is a translational equilibrium and second one is rotational equilibrium. That's why while I am dealing with rotational motion, many times I will say you have to go simultaneously. Simultaneously means translational you have to think, at the same time rotation also we have to think. Clear? This one is also rotational equilibrium. So clockwise equal to anti-clockwise. Clear? So clockwise torque we will see. Clockwise torque. Clockwise torque is nothing but it is produced by W and alpha W. Anti-clockwise torque T sin theta. Why? Because with respect to the hinge point, V and H will not contribute. V and H is not contribute, right? Why? Because V and H are acting at the hinge point. So we are calculating the net torque at the hinge point. So here the torque due to V and H at the point O is 0. So we have to calculate only W, alpha W, torque due to W and alpha W, and again here it is T sin theta, right? We will see clockwise I will write, which is equal to anti-clockwise. What is clockwise here? W into L by 2, force into perpendicular distance, right? W is downward force, perpendicular distance is L by 2, plus and alpha W into L, alpha W into L, which is equal to T sin theta into L. So I will write here L get cancelled, so W by 2 plus alpha W, which is equal to T sin theta. Clear? I will write this is 1, this is 2, and this one is 3. Clear? Now we will see one by one. Just I will erase this diagram. So try to understand the diagram, and based on the diagram only we got this equation, right? Clear? Now see here. See here, the first option we have to find which of the following are correct. So we have to check which option is correct and which option is wrong. So first one is given that the vertical component of reaction force at O does not depends upon alpha. So here vertical component we have to show. He's asking whether it is depend upon alpha or not. So we'll try to understand again. So I want to modify this 1, 2, 3 again. Just see here. We know that first one, see what is the first one here? V plus T sin theta. So I already told you what is theta? Theta is 45 degrees. Sin 45 is 1 by root 2. So here T by root 2, which is equal to W plus alpha W. Clear? And second equation, see. Second equation, H is equal to T cos theta. Theta again 45. So cos 45 1 by root 2. So T by root 2. And third equation again. What is third equation? W by 2 plus alpha W, which is equal to T sin theta. T sin theta again T by root 2. Here, just I will replace this one here. So based on that, we will try to understand, right? See here, what is the first one he's saying? He's saying that the vertical component of reaction force O does not depends upon alpha. Vertical component already we know it is V. So here from the first equation, what is the V? V plus T by root 2 is equal to W plus alpha W, right? So here T by root 2. What is T by root 2? T by root 2 I will write here. V plus T by root 2 is nothing but W by 2 plus alpha W, which is equal to this one, W plus alpha W. Here alpha W is there, here alpha W is there, it will cancel. So V is equal to W minus W by 2. So V is equal to W by 2. So here the vertical component is W by 2. It is independent of alpha. It is independent of alpha. So whatever the first point is saying, it is correct. The vertical component of reaction force O does not depends upon alpha. It is true. But clear? So now we will go with the second option, right? Now see, he is asking about the second one, the horizontal component. He is asking about the horizontal component. So H value you have to calculate. See, here we will write here H is equal to T by root 2. Again T by root 2 we will write. T by root 2 is that one. So H is equal to T by root 2 means W by 2 plus alpha W. Alpha W. But what he is saying? He is saying that the horizontal component force at O is equal to W for alpha is equal to 0.5. So substitute here. So here it is W by 2 plus alpha is 0.5. 0.5 means it is 1 by 2. 1 by 2 into W, which is equal to W. Clear? That means the horizontal component at O is W when alpha is equal to 0.5. So whatever he is saying, it is correct. It is also true. Clear? Now we see the third one. See here, the third option what he is saying is tension in a rope is 2W for alpha is equal to 0.5. So now we will calculate tension. Vertical component we calculated, horizontal component we calculated. Now he is asking about tension. So we will see here from third equation we will solve. From third equation, here it is T by root 2 is equal to W by 2 plus alpha W. Correct. Now we'll write T is equal to T by root 2 is equal to T by root 2 is equal to W by 2 plus alpha W. What is alpha here? Alpha is nothing but 0.5 1 by 2 W. So here T is equal to T by root 2 is equal to this one is W. That implies T is equal to root 2 into W. Correct? T is equal to root 2 into W. But what is saying? He's saying that tension in the rope is 2W for alpha is 0.5. But how much we got? We got T is equal to root 2 W. So which is wrong option. So this one is false statement. Right? I hope you are understanding, right? So now we'll go with the last statement. What he's saying, just we'll see. See the last one. He's saying that the rope breaks if alpha greater than 1.5. Alpha greater than 1.5. So now first what we'll do is at alpha is equal to 1.5, we will find out the value of tension. After that we will discuss. So here we know again T by root 2 which is equal to W by 2 plus alpha is 1.5 which means 3 by 2 into W. So here it is T by root 2 which is equal to what is W by 2 plus 3 by 2? 1 by 2 plus 3 by 2. So 4 by 2. 4 by 2 means 2W. That means here T is equal to 2 root 2 W. What is the value of T? That means at alpha is equal to 1.5, alpha is equal to 1.5, tension how much it is? 2 root 2 W. 2 root 2 W. But what he is asking? He is asking that if alpha is greater than 1.5, it will breaks. It will breaks. Now we'll see the question here. In the question itself, he is saying that, see, the maximum tension is how much it is? Maximum tension is how much? 2 root 2. So under maximum tension, alpha is equal to 1.5. Alpha is equal to 1.5. If alpha is greater than 1.5, tension will be more than this value, then automatically it will break. Clear? That means whatever he is saying, this one is correct. This is true statement. Correct? Clear? I hope you are understanding, right? Thank you.